You're listening to
CRST,
the podcast
from Bryn Mawr
Communications.
Welcome, listeners, to CRST, the podcast. I'll be the host of today's episode. My name is Joaquin De Rojas, and this episode is going to focus on practical applications of AI, specifically in ophthalmology, but some of these concepts can be applied for other areas of medicine as well. A little background about me. I'm a cataract, LASIK, and corneal surgeon. I'm also the director of refractive surgery at Center for Sight, which is a large practice in Sarasota, Florida. As the director of refractive surgery, I'm very interested in looking for ways to improve our refractive outcomes. And a lot of that takes data. This is how I got interested in statistics and machine learning to help in this regard. So I joined a group called Advanced Euclidean Solutions. They had the AI algorithms in place that were being used to help with IOL calculations, but they needed someone to help with the workflow, to figure out ways to make it more user-friendly for their users. And that's kind of when I came in. So I've been working with this group, and it's been fantastic because it's introduced me to real-world AI, practical applications of AI, which is what this whole podcast is about. So these guys come in, our guests, which I'm going to introduce in just a second. There's three of them. And I met these three really intelligent ophthalmologists who have a deep interest in AI. And they created a company that uses AI and machine learning to figure out and solve a lot of problems in ophthalmology. I met these three gentlemen, Taj Nasser, Gurpal Virdi, and Matthew Hirabayashi at the STAR 2023 U.S. Surgeon Summit. And I was really blown away by what they had to say. So Taj gave this amazing talk about his Volt algorithm with his group that looks at sort of how do you predict ICL sizing. It was amazing. And then I got a chance to speak to his whole team, Gurpal and Matt included. I'm going to let these guys introduce themselves further. So I'm going to give it over to Taj Nasser next.
Thanks, Joaquin. It's a pleasure being here, and thank you so much for the invite. You are too kind. Thank you for the kind words as well. I'm a refractive cataract and anterior segment surgeon at Parkhurst New Vision in San Antonio, Texas. I've had the pleasure to collaborate with Matt and Gurpal over the past couple of years, and currently the CMO of iSpace, which we are very excited to talk about shortly. I'm going to hand it over to the guys.
Hey, Dr. De Rojas, it's great to connect with you again. Thanks for putting this together. My name is Matt Hirabayashi. I'm a PGY4 and the chief resident at University of Missouri, and I'll be the next refractive surgery fellow at Parkhurst New Vision in San Antonio, where Dr. Naser is now. I'm also one of the co-founders of iSpace with Gurpal.
Yeah, thanks again for hosting us. My name is Gurpal Virdi. I am a PGY2 ophthalmology resident at the University of Missouri. Interested in going into refractive surgery, and I'm also one of the co-founders of iSpace with Matt, and we're really happy to have Taj as our CMO.
It's just so cool that you guys have already gotten so far. I remember when I was a resident, I was just trying to survive. So the fact that you guys have a successful company, in this space is amazing as you're doing your training. And I know Taj is in one of the best practices in the country. So it's just amazing to have you guys on. I wanted to start out, since this is about practical AI, I think what we need to understand better and what we need to sort of communicate to the audience is what is AI? What do we mean when we say artificial intelligence? And what about the term machine learning? So maybe Taj, you could help us maybe define what these terms mean in general. So to help our audience.
Yeah, thanks, Joaquin. So it is a very interesting topic, and I totally agree. Understanding the definition is important, and it has been defined in many different ways. The best way I can explain it is you can look at AI involving or being grouped into a couple of different buckets. So one way to look at it is there's three types of artificial intelligence. Essentially, what artificial intelligence is, it's basically defined as a field of computer science that's basically dedicated to the creation of systems to perform tasks that, as we know, require human intelligence. The three types of artificial intelligence are: one is artificial narrow intelligence. This is what's commonly available throughout. So this is goal-oriented and it's designed to perform singular tasks. So it's based on predefined behavioral models. So you can think of, for example, Google Search, Siri, manufacturing robots, chatbots, predictive texts, things like that. The second category is artificial general intelligence, which it is debatable regarding whether it exists or not, whether it is hypothetical, but essentially it mimics human intelligence and behaviors. So this type of AI learns from its surroundings and responds to them itself. So ChatGPT is on the verge of between artificial narrow and artificial general intelligence, as an example. But we're going to be looking at this in our lifetimes over the next decade or so, with the advent of supercomputers and whatnot. Now, the third type of artificial intelligence, which coming to stores near you over the next couple of decades, is artificial superintelligence. Now, this is definitely hypothetical, where this type of AI doesn't just mimic or understand human intelligence, it actually becomes self-aware or sentient, and it definitely surpasses the capacity of human intelligence and ability. So this is where it develops self-awareness and learns on its own. Now, another more practical way of understanding artificial intelligence, it has many different branches, but essentially the big umbrella of AI, and then a branch of AI is machine learning. This involves computer systems that basically uses algorithms and statistical models to draw inferences and use statistical models from patterns in data. It's basically a more robust way of grouping data. Within machine learning, and something that we're very passionate about, is deep learning, which is a type of ML in which multiple layers of processing are used to extract progressively higher levels of data. So this takes its inspiration from neural networks and the actual biological neural networks. So it categorizes data, and it, instead of basic, machine learning, it involves algorithms with layers of code that processes data and passes it to the next layer. So it consists of interconnected nodes. This is specifically powerful for tasks involving unstructured data, and something that we're very passionate about because it's great to look at images and image recognition, and is a reason why we chose to focus on deep learning for a couple of projects we're going to talk about in a little bit.
What would you say is the difference then of these machine learning algorithms? And just to recap, you're talked about, you divided up artificial intelligence into three different sections depending on sort of its level, right? And within artificial narrow intelligence, this is the part that we're focusing on here because we're looking at specific problems and we're trying to solve them. And now you're looking at machine learning, which is using machines to predict, essentially to predict and to solve problems. How is that different, like a neural net, like you described, or deep learning, which is a deeper type of neural net? How is that different than just what we've had before, which is computer programming or statistical analysis, like a regression that tells us, you can make predictions off of that? What makes it different, would you say?
Great question. So traditional computing or earlier statistics do not group and categorize data as efficiently and effectively as machine learning and then deep learning. So you're essentially finding a more robust and more in-depth way of grouping data, and you're able to create algorithms that mimic sort of how our brains work in a way, in terms of interconnected nodes, in terms of creating and processing data that's a lot more robust, especially when you're dealt with big data. So when you involve a system and you want to extract a massive amount of data, simple computer diagnostics and computer algorithms aren't as efficient and effective and able to generate an output that's more powerful, especially when you look at images. For instance, when you look at images or image recognition, you are looking at tons of pixels and tons of information that you have to categorize it. So for example, machine learning, you'll hear of various different ways of categorizing data, such as linear regression, logistical regression analysis. You'll hear random forest. You'll hear lots of other kind of ways of categorizing data, which is much more robust than the previous form of standard computing.
Thank you, Taj. I think the other the element that you're touching upon too is that with artificial intelligence, just for our audience to understand, we don't always know how it's doing it. It's more of a black box with these deep neural nets. We know that the layers are talking to each other and there's some math going on and eventually there's an output. But just kind of like how we don't know how our brains work, we kind of know how they're organized, but we don't really know how exactly the neurons are talking to each other. Likewise, we don't really know how it's working per se, but it's working. Whereas I would say computer programming is you are programming every little step. So you lose a little bit of knowledge of the process, but it becomes a lot more robust, like you said. So yeah, that's really interesting. So I wanted to kind of switch here a little bit now and get more in detail as to how this applies to healthcare and more specifically ophthalmologists, or I should say how it applies currently, but how it could also apply in the very near future. So, Taj or Gurpal or anyone or Matt, I wanted to talk about specifically, what could we use AI in healthcare or in ophthalmology for? Like, for example, images. I know you talked about that. Speech and text, like ChatGPT, all the data that we get. These are all possibilities. So, can you tell me a little bit about some applications? Maybe Gurpal, you can help out with that.
Yeah, as we continue to increase our data collection, imaging across various specialties of medicine, we're starting to realize that we can harness this data to create extrapolations, um, carry out projects that will help for improving patient care that would not have been done with such automation prior to this. So ophthalmology is actually a really good example in that it is naturally big data. It naturally lends to these deep learning models that require such a data load because we often track our outcomes, quantify patients' autonomy or anatomy with biometers, pentacams. We get a lot of structured data from this that we can actually link to a patient. Additionally, we have various modalities of imaging where we can, again, have patients with their respective imaging as well that can be used for any sort of big data projects or concepts. So, one thing that we're realizing is that with this advent of machine learning, especially with deep learning, we can provide personalized patient care and patient data through analysis with a lot of these models. So we're finding that with a lot of this data collection that is being done and data that's being harnessed, we're able to create different applications that will help to improve patient outcomes in terms of automating small tasks, reducing human error, and providing extrapolation and predictions that have an unbiased input.
And even one really practical example that I give sometimes is I'm already using ChatGPT, for example, to help answer patient messages or write pre-authorizations. There's a
Nice. I
lot
love
of
it.
immediate applications in clinic already. It's amazing.
It is. I would agree with that. So you guys we talked about all the data that's available, all the structured data that we have in ophthalmology. And specifically for us, we're a little more on the end of refractive surgery where we have tons of data about that, both pre-op and post-op. So there's tons of imaging and just so much opportunity there. And speech and text we talked about. But let's get more a little bit into imaging because I think that's kind of some of what you guys have focused on. So Matt, maybe you can tell us a little bit about, overview of what iSpace is, the company, and what's its mission in AI application.
Sure. So iSpace was started a couple of years ago when Gurpal and I recognized kind of a more simple problem than the things we're trying to tackle today, where on the IOL masters, as young residents, we would just see so many different options and try to Google them and weren't really finding anywhere that had them all together. And we later found, places like IOLCon had some inaccuracies. So we developed IOL reference, and that involved a lot of teaching ourselves to code in various languages. And the idea of just building a product and storyboarding and getting things out there. So that kind of led to iSpace, which has the mission to really equip other surgeons with more advanced tools and optimizing their outcomes too. Also, we're hoping to eventually, provide a collaborative space for a professional discourse and discussion. But yeah, the whole field of ophthalmology just really lends itself to big data and data science. So we've been working on these different projects with different refractive practices to just improve current practice using the AI technology that has all kind of been self-taught so far.
Just to for our young listeners out there, so what a part of training were you in when you guys decided to go and head first and learn the programming? Just curious for our listeners. Was this was it in medical school or?
It was, actually, Gurpal was at probably, if I recall correctly, on the very tail end of medical school. You can correct me.
Yeah, M4.
Yeah, I think when we first talked about it, though, I was, either just starting actual ophthalmology residency, which would be PGY2.
Yeah.
So, the earlier you can get into these things and start asking, just, questioning kind of everything you run into in your training, I think you'll find that there's a lot of unanswered questions or inefficiencies that you could, attempt to address, and you never know what it will lead to.
Yeah, I had just matched into ophthalmology at the tail end of my M4 year, and Matt had just finished his medicine intern year here at Mizzou, and both of us were starting to learn about ophthalmology as much as we could, and we started to notice there were quite a bit of problems and inefficiency in it, and we wanted to tackle those as we saw them in clinic and saw them in practice, and figured if we can improve the workflow and eventually maybe improve patient outcomes, improve visual outcomes, that'd be a very powerful thing. And our passion for technology kind of added to that, and we just tackled one problem and we found a few more and kept kind of going from there.
It's amazing. It's just amazing. I hope that whoever's listening to this, they realize that no matter how busy you think you are, when you're a first year resident, you're busy, and if you want to do something in this space, it's possible. So it's really amazing. Maybe you guys can get a little more into the specifics of iSpace and what were the applications that you had, because you had some pretty amazing stuff there that you built early on, and then it's really developed since then. So maybe you can tell us about IOL reference, the outcomes tracking, the iSpace exchange, all the different features and assets that you have in that. Please, Matt, maybe you can help us guide us through that a little bit.
Sure. So like I kind of mentioned, IOL reference was the place to start, which the whole idea was to collect the information with the help of reps who have been so helpful to us in developing a central database that has truly every single current FDA approved IOL on the market available today. We've also, what's been pretty cool now, because it's been going on for a couple of years, we've started logging kind of as a historical reservoir as well. So there's some IOLs that have reached end of life, for example. So the goal is to maybe 20 years from now, I'm sure, just like you and I see in clinic sometimes an old lens or a lens that hasn't existed for 30 years, it would be cool to see what it was made out of, what its refractive index, just from matching materials or anything. But so yeah, like I said, that kind of led us down the path of programming. And then we had a couple smaller ideas that we were trying to tackle just using technology previously. One example is like a digital Lancaster. And then it was really Dr. Naser that approached us maybe a year and a half ago with a really great idea that kind of gave birth to Vault.
Yeah, and that's where I really wanted to sort of focus on as well. And like you, Joaquin, I was just blown away by, Matt and Gurpal being at the stage of their training and being just way, way ahead of the curve and really innovative. And being in a refractive fellowship with Greg Parkhurst here, we always look at new technology and how we can improve the status quo. And so I looked at the IOL reference app. We get these unusual cases of high hyperopia, or what's the maximum power of lens that we have available in the U.S., or other questions. And I thought it was a pretty cool thing to do. And so I reached out to them, and one thing that we were focusing on here is how can we implement a better sort of ICL sizing modality. So we do quite a bit of ICLs here. We're known for being one of the highest volume centers in the U.S. And so part of my fellowship research project was studying Reinstein's nomogram and seeing our outcomes with that. And I delved further into the literature and found that there were examples of machine learning nomograms out there, but there wasn't a deep learning nomogram, and it was something that I was very interested in. So I talked with my mentor and connected with Matt and Gurpal, and we thought it was just a crazy idea. Maybe it'll never take off. Maybe it'll never work, and why even try? But I think it just goes to show that just having a crazy idea that you can solidify and having the right people around you and nerding out about specifics can really give birth to something that actually works. So we were pleasantly surprised. We've studied it and we created a model, and now we're continuously acquiring more data, and recently published our article regarding how good of outcome we have retrospectively. So this just goes to show you that regardless of level of training, regardless of where you are in life, surround yourself by people that are like-minded, people that really want to collaborate. And this is ophthalmology is a very tight-knit community. We're all here to help each other out, and I think we've really grown something special together, and can't wait for our future direction.
Your results are fantastic. Just looking at them myself more carefully, even after the meeting, it's really amazing. ICL sizing has always been an issue. It's gotten a little bit better now, with the Evo, where you have a little more leeway. But to be able to predict how much volt, which is that space between the lens and your natural lens, the ICL and your natural lens, to be able to predict that within 100 microns, essentially, is pretty amazing. We've never been able to do that until now. So you guys have done a great job. And just to get a little bit nerdy, a little technical here for some people, you mentioned something, and I want for the reader to understand and the audience to understand that you were talking about there were machine learning models, but you didn't see a deep learning model. So what you're talking about, correct me if I'm wrong, is that deep learning is a subset of machine learning that is a little more sophisticated, requires a little more compute, requires more data, but could essentially be a lot more very, very powerful. And it's probably the most powerful one that we have right now. It's being updated with new technologies like transformers recently and all this type of stuff. But just you, I guess, had been doing some research. You must have been, Taj, doing some research on your own and realized that there's more technology that can be applied to this problem now. It's available now. So maybe I'm just want to get in your mindset a little bit. Is that sort of what happened? And then did you just kind of reach out to these guys, to Matt here and Gurpal, just because you had the app and you saw their email on there and you're like, how did that work out? I was curious.
That's a great question. So it's, deep learning has been out there. So if you look, many decades. For example, there has been studies that showed that you can take pictures of the retina, and just by looking at pictures of the retina, you can then, looking at a deep neural network, figure out if a patient is myopic, hyperopic, or just has a neutral spherical equivalent. And I was mind blown. I was like, wow, you can actually look at pictures and have actually outcomes with just looking at pictures. And so delving into it a little bit more, I realized there are several examples in ophthalmology of deep learning, whether it's ectasia detection and refractive surgery, to predicting myopia progression, to even robotics as well. So, Matt and Gurpal, and they mentioned something very important, is you'll go through struggles in the beginning. It's not all rainbows and sunshine. We actually worked on a different project before Vault together to develop an app for DLK from a process improvement QI. So we've gone through some struggles together even before Vault. So never feel that you have to get it perfect the first time, or it's all going to be rainbows and sunshine. So looking at what's available out there, doing research, and then Matt and Gurpal have just done such an amazing job with their previous products and the company that they founded, that it was just a very awesome collaboration between us to just have like-minded people get together. So I reached out to them, and you'll network with people in many different organizations and meetings. So we even met in person at several meetings, including YMDC as well. I'd have to give a shout out to them as part of BMC. There are just amazing sort of avenues for people to network and get to know each other, because we're always open to collaborating and helping one another succeed.
Very cool. Very cool. awesome story. And again, with the Vault project, it's looking at images and it's predicting just pre-op images, ultrasound, correct? So you're looking at ultrasound images. You're inputting that as data, and essentially you're getting your prediction. You're judging it against is the actual volt that you get afterwards, which you can measure. So the machine knows what you get. The machine knows what lens size you placed, and the machine knows what the lens and the eye look like prior to surgery. So it pushes all that together into this deep learning model, and it figures out a way to optimize the sizing. Would you say that's a good synopsis there?
That is spot on. So one thing I realized, a lot of programs or a lot of nomograms look at predetermined variables. So sulcus to sulcus, white to white, and we know white to white doesn't correlate with sulcus to sulcus. So external anatomy has no correlation with internal anatomy. So there's just a lot of moving parts, and like, where do you measure white to white from? Is it the gray to gray? Well, what if a patient has this kind of anatomy? So it becomes a little bit confusing clinically. And so what we're hoping is that maybe if we look at pixels, maybe if we look at shape, maybe if we let AI do the thinking in a more robust way at looking at what's the relationship between the ciliary body and the iris, what's the contour of the iris, maybe there's that missing link that we can delve into. And we're still studying that question, and so far it's been promising.
Well, I think the cool thing too about this approach with AI and with deep learning, because I see it in the work I'm doing with my group, is it's malleable. You can add new parameters. You can change the model as you get new information or as you think up of new things. So I imagine that you guys are, you have version 1 or version 2, whatever version you're up to. But if you decide later on that, I don't know, the patient's favorite color might somehow influence the size of ICL, you can include that in the model and see what happens. Is that correct? Or
Yeah, we actually, funny you mentioned that. We actually talked about shoe size and height as well, just as a joke, to include other hyperparameter tuning. But we're planning to already. We have a couple of different variables that we're going to use to further tune the model. And something we're very excited about under the umbrella of iSpace is other products that would be awesome if Matt and Gurpal wanted to talk about how we've branched into other products
yes,
within the space of
yes,
ophthalmology.
we'll switch. I mean, there's just so much to unpack about all these, but we do have to move on. So thanks for reminding me. So the perfect test. This is another project that you guys have worked on, and it's very interesting to me because I'm a cornea specialist too, and we're always worried about when we're planning for LASIK, we want to make sure we don't induce ectasia or thinning of the cornea over time. We also always want to be able to look at keratoconus or possible keratoconus patients and be able to evaluate them and see if their disease is getting worse. So this perfect test is related to this. So maybe Gurpal, maybe you can let us know a little bit about this perfect test that you guys have developed.
Yeah. The perfect test stands for predicting ectasia risk from evaluated corneal tomography. It is essentially an image-based machine learning project that is aimed at predicting corneal ectasia development and progression. This is what we figured would be to assist clinicians in the diagnosis of ectasia and screening for refractive surgery candidates. We've been having quite a few meetings with Dr. Jack Holliday for our AI-based IOL formula that we're creating, listening from his experience, and we've always talked to him about his journey with Pentacam and the Holiday Report, and he's given us a lot of insight in terms of how to use the Holiday Report with people that have progressive images and follow up with corneal specialists, and use that data to help predict what an initial Pentacam would be as an input, and then see if there's a prediction risk that would quantify it as a percentage to say, hey, this is how much percent chance of ectasia with this topography.
Gotcha. So it's kind of like one of those Pentacam displays is the Bell and Ambrosio ad, which we use for this. So it's kind of in that spirit, but I guess you guys are looking at it a little different because you're doing an AI image-based analysis. And is this a similar algorithm that you would use for the other, the ICL?
It's a different neural net, but it's still in its very very early stages of development, where we're still kind of going through how to process the images and how to apply certain neural nets that would work best for this one. And again, this idea of deep learning is powerful for tasks just like this one, because having unstructured data like images and text, it kind of lends itself very nicely to a neural net with many interconnected nodes, especially for a complex project like this, where we're inputting sequential uh, pentacam images that will show people's various stage of developing keratoconus. So a neural net is lends itself very nicely to this, and we're finding some novel methods, especially with new models and nets out there from Facebook AI, that will help to expedite this process and make it more accurate.
That's very exciting. I'm looking forward to see what you guys cook up. It's going to be very cool. Another thing you guys are, your company has been up to is OptiCalc. And Matt, maybe you can tell us a little bit about this.
Yeah, sure. This one we're very excited about, actually, because like Taj said, you kind of go through waves with this, where you get an idea and you're really excited, and then you start exploring it, and then it's way harder than you thought it would be, and then you have to go back to the drawing board. But this one started working out pretty neatly. So the whole idea with OptiCalc is to develop a machine learning based IOL formula. The idea would be to feed it the classical demographic and biometric data from whatever biometer you'd be using in clinic, or if you like type into the Kane formula online or something. But then also feed it the OCTs that maybe like the IOL Master 700 prints out, because what we found with Vault is that it does appear that there's such a hidden treasure of information in an image based on anatomical relationships between structures, details that maybe can't be quantified, angles, just different things inside the eye that are harder to quantify and measure. So we've been training this model. I think have one of the abstracts at Askers, I think, but so far it's coming out like fairly competitive with Barrett, so to speak. That's a big claim, but there's a lot of refining and data expansion to do. But it's been really great. That one we've been working on with Dr. Parkhurst, of course, and then also Dr. Rebinich in Oklahoma is going to help us with some of the data on that too. So it's been great.
He was at the conference too. I got to speak with him. Interesting guy. So this is very cool. So you guys, just to understand this a little bit, you guys are using not just the numbers, or maybe you're not even using the numbers that you get from the printouts, but you're just actually using the images themselves, the raw images, as inputs. Is that right?
Yeah. So in a way, we've actually iterated it backwards from Vault. So in Vault, we started with strictly the very high frequency ultrasound images first, and then started attenuating the results and tuning the algorithm with patient demographic information. For the OptiCalc, first, most classical formulas, we would feed it the patient demographic, biometric data, feed it all the IOL data that's known, like design factor and A constants and lens factor and such. And then now we're starting to attenuate it with the images. Has kind of been a later step, but it's exciting to see it improve once you start introducing that. And I think that just also reinforces that there's things that, ophthalmology is so cool. I always said the Pentacam is one of the most amazing inventions. I always imagined scientists, bringing forth the Pentacam and just blowing away the ophthalmologists, because it's delivering so much more information than they could ask for. And I still don't think we understand that fully. So there's so much information available to us in ophthalmology, and I don't even know if we know how to process it yet, which is really exciting.
I'm with you, man. Pentacam is like one of the wonders of the world in my book.
It is. It's awesome.
There's so much information. It's actually amazing. We think, when I learned how to read the Pentacam as a resident, you'd look at the 4-map refractive, and I thought that was it. There's just so many different printouts and so many ways to analyze the data. And I think there's so much more to be tapped there, as well as with OCT and ultrasound, biomicroscopy, all that stuff. And it seems like given all that data, it seems like machine learning and deep learning is the way to do that. So
Yeah, it's a
I
bright
think
future.
Yeah, I always say I fear for my kids because I mean you even have studies that are able to extract so much data that they're able to perform surgical plan formulation. So you'll have patients, for instance, in a refractive surgery setting, filling in questionnaires, getting diagnostic studies, and then through complex machine learning and deep learning, able to recommend the refractive surgery option, where you don't even have to think anymore. So the future is bright, and it's very interesting how
I
technology.
hope we still have. I mean, I just hope we still have jobs. That's the common misconception. I have theories about that, but I think at the very least we can say that our jobs are changing. So I think that being able to use AI as you guys are doing, or is going to make you a better doctor. And that's I'm more of I'm an optimist.
Yeah, hopefully our jobs are going to get easier, so we
Yes.
can, focus on other things and, enhance the patient experience in whatever way we can with
Yeah,
these
less
things.
human errors, more predictive outcomes, and hopefully improve visual outcomes as well.
Good. So we talked about some of your big projects, and I know you guys have some other ones you're working on. But just in general, Taj, would you say there's a lot of what you do? You're doing a lot of different stuff, but you definitely are looking at images. We talked about how it's kind of like an image is worth 1,000 words, right? And those 1,000 words are best analyzed with AI. So, what other image-based applications you think are possible with your approaches? That you have currently.
Yeah, so we've mentioned a couple in terms of IOL formula, corneal ectasia prediction, but we even have some examples in ophthalmology as, for instance, ocular oncology lesion detection, which um, one of the collaborators is Carol Shields. But I mean, really, the world is your oyster in terms of being able to ask a clinical question. For me, in a refractive surgery setting, for sure, some of what we discussed is very relevant. But even in ophthalmology in general, and I think iSpace is gonna have that intent to be able to collaborate with many individuals, regardless of what stage of training you are. We want to be able to have more team members to come up with other clinical questions and be able to collaborate from an image detection. So whether that's smile outcome predictions or LASIK and the shape and the outcome of the actual prediction, or like really in terms of clinical questions and clinical efficacy, image detection and using deep learning is going to be very powerful. Other applications, we think artificial intelligence is going to be very important in clinic. And if we are sorry if we are shifting a little bit, but I use this on a daily basis in terms of what I do in a busy refractive practice, from using ChatGPT for, like Matt had mentioned, but marketing as well, I think, is important. So artificial intelligence is going to have a huge impact in marketing in general, as we all know. And so it's going to shape the way we do marketing in general, from keyword selection, from being able to create content, and others. So there are a lot of different applications that we use to augment our ability to improve in the marketing space and in our clinical daily interactions with patients.
Yeah, Todd brings up some great points, and one thing that we are very fortunate about is people are starting to reach out to us also to join projects or help them to get started or to collaborate. This ocular oncology lesion detection one is a really good example. Our chair, Dr. Frederick Fraunfelder, is a well-known cornea specialist and ocular oncologist, and we've talked quite a bit about how it would be nice to be able to take an image of a lesion and have some predictive value as to what it could be. And he's very close to Dr. Shields as well, and he's mentioned a lot of our projects to her in the past, and she actually was talking to him about a possible collaboration because she has quite the bank of external photos. So we're very fortunate that we're able to network and collaborate with a lot of these leaders in the field to help bring novel products to the ophthalmic space.
I saw on your website, Gurpal iLabs AI, TOS. You've worked on TOSIS classification, DMEC graft attachment type questions, early glaucoma detection. So it really seems like there's so much this can apply to. And we talked about the image based applications. We talked about the non-image based applications, the role of LLMs a little bit. Matt, what do you think about that? Is there anything? What about some of the non-image based stuff that you think could be useful here for ophthalmologists?
Yeah, so some things we've talked about is improving. Taj had mentioned earlier, the chatbot experience. I think a lot of us, when we are faced with those on websites, are can still feel like chatbots. So just making that a more authentic experience, anything to make a more VIP experience for patients. But we're always bouncing around ideas. So other things we've talked about is focusing some of these large language models on the business side of things. So like marketing, billing, data analysis, just looking across patient
I
centers.
agree. Yeah, for sure. It's very cool. So we talked about all the pros, and you guys are a great example of what showing the world what can be done. But what are some of the biggest challenges? We talked a little bit about that. You guys mentioned that there were some projects that you you didn't get some steam on right away, so you kind of shifted gears into other projects that were a little more fruitful. What do you think are the biggest challenges? So you have, let's say, you have some young, pre med student that's listening to this right now, and he or she wants to get into ophthalmology or some other field. Um, what they're going to go through this, they're going to learn some stuff. Maybe they partner with the right people, but what type of challenges are we going to face when we try to do this? And how do you overcome them?
First thing coming from the perspective of somebody really early in their career is just finding a mentor, just like anything else, starting a practice, finding a fellowship, connecting with people who are further along than you is just critical because the insight that they provide is very valuable. So like everybody's mentioned, it's been awesome now that we get to support the next generation of young entrepreneurs, so to speak, that come to us with ideas. So that's one thing. And the other biggest challenge that we face a lot is AI is awesome and machine learning is awesome, and these projects sound like they're so easy because you just plug some stuff in, but you need to have the stuff to plug in. So these AI models require thousands and thousands of whatever data set you're using. So, I mean, it's just thousands of UBM images went into Vault, tens of thousands of eyes are going to have to feed into the OptiCalc, for example. So, and then also sometimes the neural nets just don't really work out because you run into different challenges because these are all kind of GPU intensive tasks too. So we often run into a resource limitation where it would be nice to be a larger company with larger support, and then of course just other problems that would accompany the machine learning side of things, like the problem of overfitting or if the user will actually use these projects.
It's too bad you're not Facebook, because then you can just buy 600,000, what is it, H100 chips, right? That's
Yeah,
what they just.
the GPU demand is actually something that is quite important. The computational load of running these models with so much data to be trained with them. But there are cloud-based GPUs that are very useful, very affordable. Even they have student packages. So the opportunity is definitely out there to bypass those sort of systems. Fortunately, we're not at the place where we need 1 to 2 million images, which is often common on these commercial large scales machine learning models. So we're kind of lucky in that sense. And one thing also that's really important in this challenge is that you have to really think about your user. Will your product or your tech actually improve their user experience? Will it reach the goal that you need to reach for them to want to keep coming back? One of the biggest things that we've realized is the idea itself doesn't matter, but rather it's the execution that matters. And a lot of startup fundamentals like Y Combinator, Paul Graham's blogs, you know this is a resounding theme. And we first learned this pretty early when people were saying there's already IOL con out there, but we we were trying to use it, and there were a lot of lenses that were not FDA approved. The powers were wrong. They were not updated. The models were outdated. So we figured, hey, we have this idea as well, and we can do it probably at a more optimal method. And we're so surprised how that has taken off. And any country that you can think of actually has downloaded iSpace and is using IOL reference. So, but that challenge of needing to fit the user experience is really important. So it provides them a motivation to want to keep using your product.
It's really cool. You guys are learning these things even before being practicing ophthalmologists, because it's kind of a similar idea when you're building a practice, a refractive practice. I know you guys are into refractive, but you're trying to match your service or a product with what users want. And it's cool that you're learning this through the tech side as well. But it seems like it's very similar principles.
I couldn't agree more. And Gurpal said something really, really crucial. It's the execution that matters. And I mean, we can have these amazing ideas, and we try our best to reach for the low hanging fruit from just the systems and QI perspective, because it can get very daunting quick. But it's the persistence, it's the determination, and just being committed on executing your vision, because it is challenging in many ways, and we still go through a couple of issues like we mentioned, from GPU, from certain obstacles that we face. But it's really daunting, especially for people who are in various levels of training. But I feel like it's almost analogous to our current generation and starting your own practice. It's like, oh my gosh, it's probably something that's very impossible, but I mean, it is doable, and we have many examples. And I think as long as we put in our best effort, we surround ourselves with the right people, really anything can be accomplished.
This is very, very good stuff. Very good information. Just to summarize, it seems like you need to have the right technology, the right compute, they call it in the space. GPU standing for graphical, uh, processing unit, correct? And this is what this is what machine learning uses. But the other thing you guys mentioned on this regard is that they have systems in the cloud, that so you can use the hardware that's from the cloud, so that can help. Obviously, you need some expertise, or you need to hire or partner with some expertise in machine learning. And even if you have all that, you obviously need a good idea, but more importantly, you need to be able to execute. And that's going to take time to figure that out. And that's maybe where you need maybe some experience on the ophthalmology side, figure out really what is it that practitioners want, what is it that patients want, depending on your product, obviously. So my next question is, how does a person get started? We kind of touched upon this already, but is the best way to get started, if someone listens to this podcast and they're excited about AI and they're excited about healthcare, maybe more specifically in this case, ophthalmology, and they have a good idea, maybe they don't know much about AI. How do you get them? What would you tell them to do next? Should they learn more about AI, about programming in Python? Should they Is it dependent on how busy they are? Should they maybe just try to collaborate at this point? What do you think? I know we talked about young ophthalmologists, but there may also be some older ophthalmologists, seasoned ophthalmologists here that are interested in this field as well. So maybe you can give us some insight on this, Gurpal, or anyone else that wants to chime in as well.
Yeah, this is a really important topic, and something that we really encourage, because we've been there in the beginning, and we want to support others that want to create things and have new innovations that will move our field forward. Every conference that we've attended, Matt, Taj, and I have always been approached by medical students to practicing ophthalmologists. Some that we're just so taken aback that they would come to us for advice, being so well known in the field. But everybody has an idea. They go through their day-to-day clinic and OR, and they see where inefficiencies and problems lie. And what we tell them is to identify a problem and then kind of build around that. A lot of times people fall into this error and fallacy of creating a solution in search of a problem. And that's kind of where people end up making mistakes. So that's what we tell people initially is identify a problem that you want to target. Think about what is currently out there. Think about your tech stack and how you want to build that. And we realized that the best way to kind of start from our perspective is to start learning basics of programming and code. I know I was speaking to you in Tampa about CS50, the Harvard online course, which provides like a good entry level into initial code building and development and understanding syntax and what the different functions are, what libraries are, what frameworks are, and that's all really important to create
Yeah.
to start
Great
your
course,
process
by the
off.
way. Great
Yeah, great
course. Almost,
course.
almost through it. It's been rough, but great
It's
course.
yeah, and it takes a lot of time as well, as you're probably aware. It's a very different type of thinking than medicine is. You have to think each step of the way. You have to think about error handling, logic, what functions to use, and also you have to truly think about efficiency of code to reduce tech debt. You can create a lot of programs going in in an indirect approach and eventually reaching there, but that's not going to be a very good product to use. So CS50 is a good one. And then people always ask how to get into AI, and one of the things that we're very fortunate is to have a good math background, especially linear algebra. One of them is Stanford's engineering course, Engineering 108, which is free on YouTube, and that would provide a good foundation to go through and understand basics of linear algebra, matrices, vectors, those sort of things to help manipulate data, how to store data, and how to you know with that complexity. And then from there, going into more machine learning or deep learning courses, especially. So CS229 by Andrew Ng also is a machine learning course that Stanford provides for free. And then from there, CS231N is a deep learning for computer vision. And that's kind of like a good pathway to start off going. It is a lot of work because there are maybe around 15 to 20 videos per course with about an hour or so each. And a lot of times people end up starting with that motivation, but at our level as residents or practicing surgeons, life gets in the way, patients come first, and these are things that kind of prevent people from getting to that goal. So we always tell people that we're always open to collaborating. We realize that many ophthalmologists are eager to collaborate on tech projects, and many refractive practices know that iSpace has the infrastructure to develop code to clinic and prefer to work directly with us. But we always encourage people to learn the infrastructure and the basics and fundamentals if they'd like. And this is kind of what we tell them.
I love that. That's such a nice summary of a nice way to go through some of these courses. I love what you said. Start with CS50, learn a little linear algebra, start taking some more advanced courses. You listed two of them that might be really helpful for our audience. That might not be for everyone. I would say that I think for myself, I've started down that path because I enjoy it and I want to learn things at a little bit of a deeper level, but it's hard. I have two kids. I'm busy practice. But I think if you like it, you'll know. Give it some time. At first it's going to be hard, but see if you like programming. If you like getting to that level, then you can go further as a hobby. But you may not be that person, and most people are not. So if that's the case, then meet people like you guys. iSpace. There's going to be. I have a feeling that I hope you guys. Wish you the best success. I know you guys are going to be leaders in this, but I also think there's going to be other groups that come up, and that's great. There's going to be tons of people that want to do work like this. And then finally, what about collaborating with people on the tech side? You can find that don't have any background in ophthalmology per se, but I understand that there are websites and different types of ways of finding these free agents and essentially having them partner with you on a project. And is that a possibility as well? Let's say you wanted to. Is it possible to create your own project, solve your own problem, maybe even create your own startup without having to do the actual coding yourself?
Yeah, definitely. It is possible, but one of the things that is, that VCs kind of emphasize is they will always fund a technical co-founder over a non-technical one. Because even though you're the ophthalmologist and you know the intricacies of that world that maybe a developer may not know or will be way too much to tell them, there is still that loss of translation as to what exactly should be done, how to handle data, how to export it. What the surgeon wants to see is very different than what the developer would think that the output should be or what patients want to see. So it is of course possible. It's just quite the uphill battle, and we often tell people that it might be worth to try learning on your own first to see if that sticks so that you can become more of a technical founder rather than a non-technical one. And that actually has worked for some people. We know one medical student, Brian Adams, I believe, who has been learning Swift on his own, and he's created a an iOS application for ophthalmology. So there are these uh, other devs out there, but you also have to vet these people and make sure that their code is efficient, that they know how to develop well. Software engineering right now is a pretty saturated market with all those layoffs, and you have tons of people that are looking to find work and projects, but it's sometimes hard to trust a technical developer without vetting them, and that takes time as well.
Very, very good insight and advice. I really appreciate that for everyone here listening as well. Um, so, in summary, I understand it as get involved, become interested if you can. We're ophthalmologists. We enjoy learning new things, and it's very possible that you may enjoy this. It may be kind of like a mental exercise for you. That's what it's been for me. It's a new way of thinking, and it's a challenge. And if you like it, then that's awesome because you may not have to be the best programmer in the world, but the more you can learn, the better questions you'll be able to ask, the better help you'll be able to get because you'll be able to rate that help a little bit better as you know more about the intricacies, and the better you'll know what's possible. So I'm definitely think that what you're saying all makes sense. And if you really want to get started sooner, then just link up with these guys, go on their website, and maybe they can help you out. So we'll leave that there. So, in conclusion, guys, we talked a little bit about AI in general, about its role for the ophthalmologist, and we saw firsthand from this group of amazing doctors um, what the power is of analyzing visual data and predicting outcomes using these machine learning algorithms. This iSpace team is a great example of this ideal of being a surgeon, of being an ophthalmologist, but also a researcher and a technologist in a sense. So these AI-based tools are here to stay. We're seeing applications like Vault, OptiCalc, Perfect Test, some of the ones we spoke about, other applications like ChatGPT and large language models that have really come to the scene in the last 1 or 2 years. Everything is being transformed now. It's a question of who has the data, who has the compute, who has the motivation. Um, I think that the future is really bright. I want to thank you guys, the doctors here, Dr. Taj Nasser, Dr. Gurpal Virdi, Dr. Matthew Hirabayashi, for being here with me and explaining and talking to us about your journey and offering us all these insights. I know that for myself, it's been really helpful and inspiring. And I know that our audience members are going to feel the same as well. I also want to thank Michelle Corey and the CRST team and Bill Wiley for helping us link together. I want to thank you guys, the listeners. And I want to remind you that if you want to know more about this amazing group, go to ispace.ai. That's www.eyespace.ai. And if you want to know more about the Volt project that we discussed about ICL, you can go to www.iclvolt.com. So that brings us to the end of today's discussion on AI in actual ophthalmic practice. It's truly an exciting time to be an ophthalmologist as we embrace the era of AI and its transformative impact. For those looking to delve deeper into the topics discussed, please see the websites that we just mentioned, and for additional resources and for in-depth information. Signing off for CRST, the podcast, I'm Joaquin De Rojas. Thank you for tuning in.
For more shows like the one you just listened to, check out the podcast channel on itube.net.